program going? All right. Dr. Julian Davis will introduce our next speaker.
Hi, everybody. I have the unique pleasure to introduce Lucas Borman, Tyson Miller, and Cameron Reed, and I think you will all be very interested in the topic they'll be talking about. So I'll hand it over to them.
As Dr. Davis said, my name is Cameron. This is Tyson and Lucas, and that was Julian Davis, our advisor. And our project was to design a wood shading distribution system. Some acknowledgments before we get started. We'd like to thank Dr. Davis for being our advisor and helping us through this, Don Moore for everything, Dr. Mitchell for allowing us to graduate, hopefully, Dr. Kissel and Dr. Smith for giving us feedback on previous presentations, Brendan and Casey Bonifer for making this all possible, our families for being there, support, and all the turkeys. So most of you eat turkey at least once a year, but do you ever stop to think about where they come from? The commercial turkey farming process has 3 parts. The first is the egg-laying operation, where the eggs are collected and cleaned. The next is the hatchery, where the eggs are hatched and reared to 5 weeks. Next is the grow-out operation, where the small turkeys are raised to 14 to 18 weeks when they weigh about 25 to 32 pounds. Our client is Bonifer Turkey Farms. They are located approximately 60 miles northeast of Evansville in Ireland, Indiana. Their operation consists of 3 barns, 500 feet long by 40 feet wide, and they hold approximately 6,000 turkeys apiece. Bonifer Farms is a grow-out operation, and this is where our project will lie. So, some turkey drive or definitions before we get started. Cake, the delicious mixture of poultry excreta, spilled feed, feathers, and bedding material. House, a term for a poultry barn. And batter or litter is wood shavings or other material used as bedding. So the grow-out cycle. The first step, we have empty barns that are dirty from the previous turkeys. This barn is then prepared for the new birds. The birds then arrive and they grow to their desired weight. Then they are removed and the cycle starts all over again. So you can see in this picture an empty barn. The turkeys have just been removed. There's still the delicious cake on the floor. Next step, the new bedding is arrived and delivered outside the barn in a large pile. And at the same time, the cake is removed from inside the barn. Next, the bedding is moved inside the barn. It's then spread to a level depth. And as you can see here, a final leveled floor of wood chips. Oops. Apologize. And all the steps again. And our project will encompass the last 3 steps. So the objective of our project is to design a machine that will distribute wood shavings to a uniform depth of 4 to 6 inches over a 20,000 square foot area in less than 4 hours. So some constraints. We have to deal with time. The present process takes 4 to 6 hours. So for our project to be viable, it needed to be less than 4 hours. Some physical dimensions as well. Our machine needed to be less than 6 feet tall. As you can see in the picture, this is the lowest point in the ceiling of the barn. It also needed to be less than 15 feet wide so that it could fit through the doors of the barn. And some requirements. The client had some requirements initially. The machine needed to be able to complete the process in less than 4 hours so it would be viable. They also wanted it to be pulled by their tractor and to be loaded by a skid steer. Also, they needed it to be spread to a uniform depth of 4 to 6 inches to conform to the regulations to make sure that the turkeys stayed healthy. And also minimize user input, meaning lessen the amount of work needed to be put forth by the operator in the use of the machine, and then again, the physical limitations, which I've already outlined.
So this is, can you hear me now? Sorry. This is the client's tractor. It's a Kubota L3800. It's capable of producing 36 horsepower, and it delivers 30 horsepower to the PTO. Power takeoff is a device which transfers mechanical energy from the rotation of the shaft. It's located at the rear of the tractor. And here's a zoom picture of it. The client's skid steer is a Bobcat. It's capable of producing 61 horsepower, and it is able to lift 1,850 pounds to a height of 10 feet. The skid steer is a small, rigid frame machine that's capable of accepting a wide variety of attachments. And before we started doing the design, we looked to see if there were any available options for the project. Finding that, there's three: the housekeeper, the honey spreader, and the wet line spreader. Reminder of the requirements: the machine shall be able to complete the process in less than 4 hours. It shall be pulled by the tractor and loaded with the skid steer. Spread the material to a depth of 4 to 6 inches and minimize user input. And it also has to be less than 15 feet wide and 6 feet tall. So we reviewed the three commercial options. First one, the wet line spreader. It is too high to fit in the barn. We contacted the manufacturer and they didn't have any information on the power takeoff requirements. So that one's out of the question. The next one, the housekeeper, it does meet the height requirement, but it requires much more horsepower for the PTO. So that one isn't viable. And finally, the honey spreader, it meets both the height requirement and the PTO power. But as you see in this video here, it doesn't do a very good job of spreading out the material evenly. So our objective, just a reminder, is to design a machine that will distribute wood chips to a uniform depth of 4 to 6 inches over 20,000 square feet in less than 4 hours. This here is a picture of a honey spreader. It uses a horizontal auger, which is a mechanical mechanism that uses rotating helical screws to move material. It's driven by ground driven, which is by the rotation of the wheels. As you can see here, the wheels rotate and turn the gear, and it turns the auger and delivers the material out the back of the device. Next, this is the wet line spreader seen earlier, this broadcast spreader. It's a machine that consists of a hopper positioned over a horizontal thin disc, and it moves material from falling out and to the rotating disc, and it goes away from the vehicle. Here's an example of it. And the final option for the spreading mechanism is the box spreader. It is an implement that's pulled behind the tractor to spread and smooth the contour of the material.
So we broke our wood chip spreader into 3 different subsystems: power, spreading mechanism, and the container. The first thing we'll talk about is power. So we're taking design cues from the things we've seen before. We decided to go with either a PTO-driven or a ground-driven system. We evaluated these on two criteria, simple and design. Simple means the number of moving parts. And in comparison, the PTO and the ground-driven system, the PTO had just fewer moving parts total. In design, what we mean by that is that a ground-driven system would have to be designed from the ground up, no pun intended. So that would take a lot more work on our part. The PT was already there. So based on that, we decided to go with the PTO. The next thing we'll talk about is the spreading mechanism. So once again, our three options: horizontal auger, broadcast spreader, box grader. Now, the first criteria we evaluated these on was desired depth. How easy was it to get the machine to spread at the desired depth that we wanted? The horizontal auger and broadcast spreader, they can do it. It might take a lot of calibration. So based on that, the box grader is what we chose. It's simple. You just set it to the height you want it and go. The next criteria was the number of passes. That's how many passes it would take to completely cover the floor of the barn to the depth we wanted. The broadcast spreader was the best. As we saw in the video, it throws material out. It covers a lot of area, so it requires the fewest number of passes. Whereas the box grader has to cover every square foot of the barn, so it would take the most, with the horizontal auger being somewhere in between. So for this criteria, broadcast spreader wins. And simple, again, number of moving parts. Box grader really has no moving parts, where the broadcast spreader has quite a few, with the horizontal auger somewhere in between. Based on that, we went with the box grader. The next thing we'll talk about is the container, what we're actually going to put these wood chips in. So, a box and a funnel. So we evaluated these on two different criteria: capacity and user input. For the given dimension, the box is going to hold more than a funnel. So we chose the box. But for user input, you put a bunch of stuff in a box and start to dump it out. Sometimes things get stuck in the corners. So that might require someone to get out and actually manually move the stuff away. So neither of these options work. So we decided to go with some sort of box funnel combination, or a funnel. So a quick recap: power will be PTO, spreading mechanism will be the box grader, and the container will be a box funnel. So our proposed configuration consists of the tractor up front. The next comes the box funnel, to which the box grader will be attached. So here's our concept of operations, how we think this thing will work. So the machine will be coupled to the tractor, the PTO will be connected, and the box grader will be adjusted to the proper height. The machine is loaded with litter, enters the barn, put in position, flip the switch, turn the machine on, stuff starts moving. After all the litter's been spread, turn the machine off and exit the barn. Lather, rinse, repeat however many times you need until your floor is covered. So from what we'd seen before, we took the design cues and we made a box funnel. We used an auger system to move material. The PTO will be attached to this shaft. Rotary motion to rotary motion is pretty easy. So, once again, PTO is connected here. Stuff goes in here. All the augers are synchronized by gears. The material will be added to the hopper, move along the hopper by means of the augers, and drop out the end, right here, in front of the box grader.
So to come up with the dimensions for our final design, we needed to come up with some time estimates to ensure it came under the 4 hours required. So the first segment was the preparation time, coupling, uncoupling, and adjusting. The next was the loading time, how long it would take to actually load this, however many times needed to fill the entire barn with litter. And the next was the spreading time, how long it would take to actually spread it and maneuver to get the job done. So this is the final dimensions of our design: 15 feet long, 5 foot high, and max width of 10 feet wide. And this is the final configuration with the tractor being in the front, Then come the container and the box grader at the rear. So we made some time estimates once we had come up with our final design to make sure it came under the time. We estimated 7.5 minutes for hooking the PTO up, hooking the container to the tractor, and adjusting the box grader to the proper height. Next, 1 hour and 15 minutes. This is for 21 loads, 3.5 minutes per load for the 1 hour and 15 minutes. Next, 1 hour and 30 minutes to actually maneuver around inside the barn, and 14 minutes to actually just spread the litter. And then 7.5 minutes to finish up and uncouple, etc. This came to a final time of 3 hours and 20 minutes, which was under the 4-hour time limit required.
We then looked at a cost analysis on how much it would cost to build this device. With all the sheet metal, with the box, along with the conveyors, and all the tablet, the total came to $35,000, $35,300. Cost comparison, we looked at how much it would cost to purchase a new tractor and also the housekeeper as seen earlier, and it turned out to be $10,000 more to purchase a new tractor and a new housekeeper. So we went back over requirements, make sure we had everything, and the machine was able to complete the process in less than 4 hours. And it will be pulled by the tractor and loaded by the skid steer. The machine shafts is spread a little bit evenly, and eliminate, reduce user input, and that is size requirement.
Any questions?
All right, questions? Could you talk to us how you maneuver into the corners so that you're able to spread evenly into the corners in the building?
Well, it all depends on your backing skills. It might not get completely in the corners. I mean, they currently do it with a skid steer now, so they can still use the skid steer to tuck into the corners and get anything that they can't get to with the device.
Have you considered any other deposition methods besides the screws, like perhaps a conveyor belt?
Yeah, we looked at a conveyor, but we thought since we already had the PTO and it was already rotating, that it would be a lot easier just to go from rotary motion to rotary motion.
Very good work, guys. Question I had was the bundle. I like that name. Make sure you get a patent disclosure on that first. Was that like a conceptual design, or is that something that you purchased off the shelf?
Oh,
With all the loggers and the gear training and all that?
well, the screw conveyors would be purchased, and the sheet metal would just be custom fabrication.
Okay, so it's a custom design.
Yeah.
Did you get as far as doing like a horsepower load calculation for the augers?
No, we did not.
Very good though.
Any other questions? All right, let's let them off the hook. Give them a hand.